Okie dokie. Let's try this. Oh, Facebook streaming is confusing, guys. It's really confusing. I don't know like where the chat is. I see a lot of stuffs. I thought I updated the title, but it's not. Typical Swift programming. How about now? Okay. Oh. Okay. Okay. I think I am live with 85% of confidence. Yeah. I'm guessing comment is what. Okay. So on Facebook, there's a section called comment, latest comment, right? And when you pop it out, the window now in the title says chat. Great job, Facebook product designers. Okay, okay. So now I know how to read. If anything, if anyone talks to me on Facebook. Okay. And still struggling a little bit. Sorry about that. Sorry. We'll start very soon. Okay, here we go. Great. Okay. I guess this will have to do. Okay. All right. Hi, everybody. It's Wednesday, and you know what that means. I'm gonna stream a little bit, work on some side projects. I'm not too firm about what to work on today, but just before stream, as usual, I kind of landed on a few ideas. So we'll see how it goes. Okay. Yeah. First of all, let me just blow this up for you. Blow this up. Okay. So it's probably easier to read. Let's go to Pathos 2. So last stream I spent, well, I'm not sure about last stream. Was it last stream? But sometime last week, I spent an awful lot of time writing about, oh, well, it's not even a Git repository. Let's do that first. And let's use a different, well, let's make an empty commit. First initial commit. Well, make an empty commit. Okay, now that we have the commit, we can tell Git to give us a new branch. Sorry, not this one, the good one, and we can blow the default one out. There we go. Okay, so I'm just gonna, I guess this is a good way to demonstrate where we are. So this is like literally a bare bone Swift PM project, and inside is some generated code that doesn't matter for now, and literally there's just one class, right? Let's just open it up in Xcode, I guess. in this one object is, wow, the Xcode is tiny. Xcode test. Oh, source code test is not bad. Okay, so this is all we have here. What it is a object called path, and it has one stored property, path bytes, and it's a contiguous array of C characters. All right, and it has two initializers. One takes the string and literally just calls the other one. Which is interesting. I'm not sure why. I think path bytes could just be string dot UTF-8 string, right? Wait, why does it not build? Oh, yes. Okay. So I guess I'll have to delete the test for now. Or should I? Okay. That's fine. Actually, this is even better. Perfect. Okay. Also, it's building for iPad. Not sure why. All right. Okay, so this is interesting. I forgot why this was like this, but this is even better. Because our storage is literally a contiguous array, and lucky for us, the Swift string type has a built-in accessor, I guess, to the string that literally gives us a contiguous array of C char. So it's perfect. Incidentally, I picked this type out through some iterations. If you were on that stream, you know, like I went through a few iterations, but I landed on this kind of organically, and later I discovered, this is nice. So that's proof that we did something right. Okay, so let me just, I guess, commit this code, and let's call it create path object. Okay, so we're gonna work on this some more today. I think one important aspect of a path library is to tell you information about the path, right? So path could have, or whether it's an absolute path, does it have a drive on Windows? Does it, what's the file name part of the path? What's the, things like that, right? So let's make a type to represent various information like that. So I'll put it on the bottom here. Let's call it parts. And what's in a parts? We will have. Well, here's the interesting thing. If I'm ambitious enough, I would make every stored property just a reference, or even just arrange that into this contiguous array, right? If I'm ambitious. If I'm less ambitious, I would make them contiguous array, just like the path bytes. So obviously the ambition here is, if we do everything right, these parts won't require new storage, separate storage for the bytes within the path. That is interesting. But that also implies, for example, things such as, we probably are committing to the fact that this path is a value that's super immutable, right? Every time you want to modify its parts, you also only modify you basically recreate the value, which interestingly, we did use a let here. So it's already immutable. So it goes hand in hand. So if you use let here in your final storage, then you might as well use, let's say, references into the storage in your parts. Because, yeah. but there's another concern, I guess, usability concern here. If there are references into the path, that probably means it probably means, let me think. It probably means we need to have separate getters as public interface for various parts, because users probably don't care about the index into some storage. They probably want some bytes, for example. And secondarily, they may want things like a string, to show their users maybe. Yeah, so there's a lot of design decisions to be made here. Yeah, so this stream, I mean, this is the bootstrap process, right? Once we have this this storage part done, I have huge amount of code that's already ready for, we can just take in here, and we'll make a lot of progress. But at the initial part is difficult. It is difficult. So let's say we make a copy for everything for now. Okay, so we have a drive, and it's gonna be a contiguous array of cchar. Should it be optional? No, empty array is the same. Okay. So we have a drive, we have a root object, contiguous array of cchar, just for consistency, even though I think, some roots are weird. Like there's a thing on Windows called a UNC drive or something. Its root is actually a bunch of letters. It has a whole name, I think. Very soon we'll start looking at Python's pathlib code, and then we can steal ideas from there. So for now, I'm just kind of winning it. Okay. So there's also going to be, I guess, folders, or we can call it directories, and it's going to be an array of contiguous array of characters. And this is kind of self-explanatory. You have a list of directories, and then you will have a file name. And again, it's going to be a contiguous array. There's some more things we could do. For example, instead of instead of having a file name, we could do like a base name. Contiguous array of characters. And then an extension. Contiguous array of cchar. So, obviously these two could be, I'm not sure. It really depends on if we were to do everything right, we should do a usability study and go out to every piece of code. This is having some kind of machine learning will be helpful and analyze like, oh, which is used more often, right? Do you use the base name of a file more often, or do you use the full name of the file more often? And then we optimize for that case. But for now, I'm just gonna make a guess, and also just to make my life a little simpler. So there's the root and then the directory. Am I missing something? A path. Let's say these are the paths, okay? And then we'll have a public. This is also very interesting. We can make it lazy. Public lazy var parts. Oh, not public even. This will be internal or even private. And the parts will be type parts, obviously. And then if it's lazy, we can, well, here's another, yet another design stop point. It's like, should it be lazy, right? Obviously, we're trying to squeeze out every last bit of performance. So chances are you don't care about the detail of a path. So you may only care about, okay, we grab the path from the POSIX API or Windows API, and then we use it, right? We use it to, traverse the content of a directory, or we use it to read or write to and from and to a file. So in that case, why pay any price analyzing these details, right? You never need any of this. All you need is this storage. So maybe lazy is the correct design decision. So so I guess we'll make a private parse function, and it give us the parts, okay? And then here we just call it, right? That's easy enough. Okay. Parse parts. Parse parts. All right. Cool. Yeah. I guess we can start implementing this. Or we can check our designs. Let's do both. Let's check our design by looking at Python 3. All right? Python 3. And we shall, I know something about pathlib. So pathlib, okay. So we can look at what's in pathlib like this, right? Ignore all the underscore stuff. So there's a thing called POSIX path and NT path. So in their design, they have a class hierarchy where you have a what should we call it? A facade class. It's a facade pattern, I think. You do have a thing called path, I believe. So pathlib.path. No? I think it should have path, but yeah, okay, it's uppercase, yeah. Yeah, you have pathlib.path. It's an object, but actually, depending on your native platform, you would get either a POSIX path or a Windows path, right? So if I create a pathlib.path, say with this content, uppercase, I would get a POSIX path instead, right? So they're using this facade pattern. I guess in some cases you do, for some reason, want to create a Windows path on POSIX or vice versa. I think more common case is like you want to create a so-called pure path on the other platform. For whatever reason, right? The pure path doesn't require any I/O to exist, so that's a nice part of that. But I digress. I think our goal here is like I'm gonna make a path P, and then just peek into the path and see what it has. Okay. So again, we're gonna ignore everything with underscore, and then we can just look, right? Absolute anchor as POSIX as URI, change model. Yeah. So yeah, this is like where you hand everything. Okay. So I believe if you do this, you obviously have a drive thing. This is POSIX path, so drive is going to be empty. And then you could have things like parts. Let me make a more interesting one. So A, B, C. Okay, and let's assign that to P. And then we can like a P.parts. So parts includes the root, right? But also I believe there's a thing called root or stem. Oh, stem. Let's make it even more interesting. abc.swift. Okay. So parts now have literally everything, including the root itself. If I say p.stem. So stem is okay. And then suffix is .swift. Interesting. What about something like a root? Yes, so root is this. Now, what's parent? Parent gives you a path that, yeah, okay, interesting. Rename, replace, read bytes, parts, parents, p.parents. It's some kind of object. I'm assuming it's going to be an iterator or something. Okay, so we have drive, we have group, home, is absolute. Some of these are obviously requires I/O, so we're not going to touch it. Actually, it's easier to make a pure path, right? So if I say this is a pure path, again, it's going to be a facade. So P is going to be a pure POSIX path. And then we can look at what's under P. Yeah, so this is easier to look at. So I have underscore parts, underscore root, drive, name. What's name? Okay, so name, stem plus suffix equals name. Okay. Parts relative to suffixes. Oh, suffixes. P.suffixes. Okay, so what if I make it even a little bit more interesting? C.d. So now suffixes are 2. Okay, there were 2 of them now. Interesting. Anchor. What's anchor? P.anchor. I think in this case it's going to be the same as the root. Okay. And anchor, I believe, is we can look at the documentation, obviously. Python 3, pathlib. Anchor. Anchor is a concatenation of drive and root, right? So on POSIX, anchor is root, and on Windows is drive plus root. And yeah, root is a string representation of root, if any. Okay. Name, stem. match. Okay, so obviously this is a pretty neat set of options to think about. No, this table might help a lot actually. Same file, blah 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 blah. Yeah, maybe this is our goal. Like we can just implement all of this and call it. But okay, that's step one. We looked at some documentation, try to get a rough idea of what's needed. But now we're gonna actually go into the CPython source code. Okay, and we're going to go to lib and I don't know, find the path lib for me. I think it's somewhere in here. Oh, this is test. Wait. pathlib.py. There we go. Lib, pathlib. Okay, so now we can actually look under the curtain and see what is actually being stored, right? So for example, there's a thing called parts. Parse parts, okay. Right. So one of the interesting thing is when you create a path type from Python's path lib, you actually get to give it multiple paths, and then that's how you join existing paths. One way to join existing paths. So that's why you have, when you parse the parts, you have yet another thing called parts. But all we care about for now is, I guess, what to do when you have one part. So yeah, so here we go. Take the part, right? And then we have a thing called split root, which gives the drive, the root, and I don't know what this REL stands for. And then we take the, okay, we split it, and then we append. We have some string turning here for efficiency. Split root, drive, parsed, reverse, parsed. Okay, parsed starts off as an array. We split the rest of the string by the separator and remove the dot. If x and x is not dot, we put each thing in here, and then we return them. Okay, so that's the parse parts. So what happens if you call it, right? Parse parts. It's called here. Pattern parts. Okay. Let's see. Okay, so there's a thing called parse args from parts. All right, so this is what they store. They store a drive, a root, and parts. Drive, root, and parts. Then what do you do with name? Let's see, def name. Name is like, so you take the underscore parts and say if length of parts equals 1, if drive or root exist, otherwise 0. Well, say, okay, this is interesting. Let's take it step by step. If you have a drive or a root, right, then having one part means you don't have a name. That means name always have the The final part of the path always is a name. Sorry. Yeah, ignore this part. I'm just doing some random stuff. Python 3. Okay. Import pathlib. Then p equals, let's say pathlib.path a, b, c. Then p.name should be c, right? Okay, so it's just the last one. P.parts. Right, parts always include the root. What about the definition of root? No definition of root. Wait, there is a definition of root. Parts, root, and drive. I'm slightly confused. So in their design, I guess parts includes the root. So that's unexpected. Yeah, I guess it kind of makes sense. Let's call this segments. And we can get rid of name because a path doesn't always have a name. That makes sense. File name. Why do you need to store root separately then? I guess to signify that root exists. Yeah. Okay. That's fine. That's fine. Okay. So the last decision I need to make is, do I want segments to include roots, right? Has drive. Aha, okay. So this is where I guess at the beginning of the string we talked about having indexes into the storage, but if we want to duplicate the root as part of the segments, right, then we cannot possibly use index into the storage. That's a good thing. That's a good thing. But I mean, it doesn't have to be like this, of course. Yeah, I wonder how many people actually use the parts thing in Python. Yeah, unclear. Okay, anyways, let's let's implement a little bit of this. So for now, I want to have segment and root be distinct. And I guess we can add a bunch of public interface for these. So we'll have a drive thing. It's a contiguous array, and all it does is return parts.drive. And critically, because parts is lazy, therefore, accessing this may trigger some calculation. Public var root contiguous array char public var segments gonna be arrayed. Oh, do I need to expose these at all? Path.root. Okay, it's fine. Just an array of contiguous array of C characters. Cannot use mutating getter on immutating value. Self is immutable. Mutating getter. Why are these mutating? Can I say non-mutating? Func declarations. Okay. Parts. Cannot use mutating getter on immutable value. Self. Self is immutable. I'm slightly confused. Slightly. Right. Maybe the best thing to do. Right, if I make this let, I'm sure things will work. We can just say something like parts equals parts. Oh, no. Bytes being contiguous array of char blah blah blah. Make it this static, I guess, and then self dot path bytes. Oh, right. Okay, so this all works. So I see. Because okay, so making this lazy also makes it a mutating thing. Yeah, accessing a lazy property on a struct mutates the struct itself. That makes a lot of sense. But if I can make this lazy, if I can't make this lazy, yeah, I guess this is fine. We just have duplicate storage here. For speed. Yeah, so now I'm trying to decide. I'm trying to decide whether we store things like these in addition to the path bytes for the path, or do we just store indexes? Because we move the computation to initializer. So as soon as you instantiate a path, we parse it and then we have these parts, right? We have the information for the parts. Now it's just a matter of how to represent the information. Um, yeah, how to represent this. So let me. Ah, okay. I'm overthinking. I think one of the things that could happen during the parsing, as we saw earlier from the Python implementation, is removing this single dots in the path segments. So normalize the path in that way. Yeah, I'm curious. I'm curious. Let's see what Python does, right? If I say p dot parts, actually, uh, if I make a path that has things like dots in it, it how is it doing it? It doesn't even store the original object, does it? That's annoying. That's not very performant, I guess. POSIX path. Okay, let's try again with pure path. It's gonna be the same thing. And then we can look at what's in the P parts root anchor as URI. Let's look at as URI. As URI is absolute. Make URI, okay. Make URI, blah, 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 blah. URL quote from bytes. Drive. As POSIX. As POSIX. Okay, so it implements the string thing, which is this. Format parsed parts. Yeah. Man, am I gonna change it to this representation? I guess. It's not as fast as I'd like it to be, though, unfortunately. My original plan is you get a path, and it could be literally just a copy of the C string buffer you get from some C API, and that way it ensures the maximum performance, right? But the problem with that is you. It's fine. We store the parts. And we throw away the original bytes. No, that's really slow because sometimes you want to iterate over a big directory. Let's imagine like it's actually already I have use cases for that. And immediately you want to say you're interested in just a subset of the directory, but you're iterating over everything, right? We don't want to say like given every object in the directory recursively, do all the parsing work. That's just super wasteful. It's looking more and more like our path needs to be a reference type, which is unfortunate. But it does solve a lot of problems we have. Okay, let's think about this. So we'll make a class inside that's called storage. And the storage. Yeah, and then we'll have a private reference to storage. And then we'll have, I don't know, enum, I don't know, state. And then there's like a parsed state, which has the drive, contiguous array of char, the root, contiguous array of char, and the segments, contiguous array of char. And then there's raw. It's just a contiguous array of char. Something like this. No. It makes more sense to have the raw bytes being this. And then I don't know. So what am I trying to accomplish here? I want to have, basically, I wanted to have the bytes, to preserve the bytes, raw bytes efficiency, right? So fundamentally, you have all the bytes. And then I want to have a storage. It doesn't have to be storage, but the thing I want is have some lazy things here. And then when I access it, it's not mutating. Okay, so let's make I don't know, is it just like a box? Wow, this is dangerous territory. Okay. So what if I just put parts in here, right? Parts. It's going to be a var. And it's lazy. Don't need this anymore. Lazy parts equals I don't know, path dot parse parts. Right, the parts here is going to be essentially this. And then I'll just try one of these, right? So if storage dot parts is nil, storage dot parts is self dot parse parts, self dot path bytes, return storage parts drive. This okay? Yeah, we can get rid of these now. Oh, yeah. Don't need this to be lazy. It's just a box. Now what? Right, storage. Ah, so this works. Okay, so we box it in. We box it. Okay, so it's not really box. It's a box. Parts. Parts box, parts storage. I think we'll just call this parts. Storage. Okay. Okay, parts storage. This doesn't have to be private. It can be public, because in case you want to ensure performance, you can just call it. And all it does is do this. Okay. Parse parts. Then parse parts here. Okay. Same thing. Let's call it cache. Parts. Parts cache. Something like that. If let parts cached parts equals self dot parts equals cached parts. Otherwise, we have to make a fresh one like so, and then we return that. Okay. And here we simply say dot drive. Same thing here. Dot root. Parse parts dot segments. And we'll also have a public version of this. Func parse parts. And it doesn't return anything. All it does is call this function. Parse parts. Okay. Okay, so let's see where we are now. So now we have a reference. We basically added a new storage that's a cache, right? Creating the cache is trivial because the cache simply has a value in it that start off being nil. So this part should be pretty fast. And let's see. And by default, it's nil. If you never access any of these functions, any of these interfaces, that part will remain nil, right? But once you do call of them, one of them will will do the necessary computation to generate these values. And from that point on, you will get the cached value. Okay. Do we have a problem with, let me think. Yeah, because now we've introduced a reference into the struct, right? That means copying structs around also copies this value reference around. Is that a problem? I don't think that's a problem. That's not a problem. Yeah, it's not a problem. Okay, interesting. Interesting. So all of this consideration is done without even writing the actual logic of parsing, right? We're just playing around with like what's the most efficient way to do this. So let me see. Now if I have a crap ton of paths that I need to create, well, let's say some POSIX API gives me like 10,000 paths, right? What will happen is we will create this object that many times. Each one will have a buffer of bytes for each of those. Copied into its storage with stirdup specifically. And that's all the computation we do, right? This is literally all the computation that happens. Yeah, I like that. I like that quite a bit. All right, I like this. Actually, probably need to use this one anyways. Code pathos 2. Create lazy parts. And what I like about that is everything is hidden. As a user, you shouldn't worry about the paths and all that. So struct, we can make this private even. Okay. Okay. So let's implement this. I think this is a good stopping point. Once I implement this, we can call it. All right. It's not gonna be easy though. Let me think. So we need some logic to split off the drive. We can skip that for now. So yeah, to do implement split drive splitting logic. Yeah, if we simply ignore the Windows complexity, this function should be fairly trivial to implement. Right, so we have the bytes, we have the character value for the separator. So we can say we just return bytes starts with, well, bytes dot first is self dot separator byte contiguous array repeating oh, it takes array literal. Okay, so we can literally say self dot separator byte. Otherwise it's this. Okay, that's easy. Oh wait, that's not root. That's this. Okay. So root will just always do empty, and segments would be literally just bytes dot separate or split by self dot separator byte, and then map it to contiguous array. Does this work? Oh, it does work. Okay, this seems too simplistic in the sense that we didn't filter out, for example, things like the yeah, we need to do a filter here. So bytes split map. Okay, so we can do filter $0. Oh wait, do it later, right? Filter $0 isn't I don't know. Current directory byte is dot. It's current directory byte? Sure. And this probably needs to be private, to be honest. Okay. Current directory byte. Why is this not highlighted? Oh, it's because of this. And okay. So we've implemented the normalization here. And we can write some tests. I don't know. Parts parsing tests. Parts parsing. Okay, and then we can say test. What's the most basic test we can make? We can test root, right? Test root parsing. Test root is parsed. Path string root. Let p equals path string root. XCT assert. P dot root. Assert equal p dot root and path dot separator byte. Oh, this throws? Why would it throw? There's no reason to throw. I hope. Okay. It's better to do it this way. C string. Wait, can I do something like C char? Wow, let's begin with this separator byte 0. Oh, that works. Beautiful. C char. Can't reassign buffer. What's the length here? Length, please. Variable not readable. Okay, let's round it back. Length is 1. Okay. So this is illegal. Inside the closure, set the initial count parameter to the number of elements initialized. The memory in the range buffer must be initialized at the end of closure's execution. Right. Okay. Buffer. So in the sign, you can do it's a buffer 0 equals C string. Okay, so suppose we have to do this for I in 0 length, buffer I equals C string. Can I do this? I assume it's not okay, but maybe? Radical. Okay. All right. We're good. In fact, this is probably better represented by advanced by I. And then, yeah. Offset. Okay, so that's actually very interesting because what we've just tested is initialization. So string, well, pass initialization tests. And here we import axitest, import pathos, and then we say final class string path initialization tests path test case test initializing from C string. And thanks to Swift, that's super trivial. Cert I guess we can say expected path is ABC, and then like CT assert path C string expected path. It's the same as expected path dot C UTF-8 C string. Oh, path bytes. Yeah, I guess we can just call it bytes instead. Yeah. We can rename this. Name this to just bytes. And we can also make this guy bytes. insert true. Oh, equal. Okay. Right. Drop last. Okay. So we can make it this like this, right? Subsequence. Yeah, okay. Test initialization from string. Virtually the same thing, except this time we're calling string instead of C string. Oh. Oh, we already caught a bug. We already caught a bug. Okay, let's fix it. We write a test fails, we fix the test. Yes. Okay, now the test should pass. Whoo! What a ride, what a ride. Okay. So what do? Did we change anything here? No. We did change. Oh, we removed the throws. And then we fixed this. Okay. Can't split. Let's edit. I want to include this, but not this. Oops. And then not this. Actually, yes, that. And no to this. Something like this, right? Yes. Okay. Yikes. Okay. Make initializer not non-throwing. Okay. Then we fixed a few things. Edit. I want this gone. Yep. And then here we name bytes. Inside we run a for loop. Okay, this is good. This is good. Forget about the parsing thingies. Yeah, I can delete this. All right, and then we have a new file here. It's as if I did everything in the right order, right? In this patch, we've got a renaming of the variable. We re-implemented where bytes is from. And we did the same thing here, except we dropped the last character. We write some test for it. Test is passing, supposedly. We delete the old test, okay? And then we probably need to do Swift package generate. I don't know. Swift. What is it? Generate something. Code pathos. Make file. Generate list. So okay, Swift test. Generate Linux bang. Oh right, that will generate a bunch of extra things. So what I should do is commit this, call it rewrite initialization logic. Stash everything and run Swift test generate again. Right. Now there's a syntax error because path.swift wait, where? Line 49. Wait, I thought I stashed this. Create lazy parts. All right. 49 is bytes. Okay. All right. It's not too bad. Okay. All right. Then we take our stashed stuff back, revive it. Got some conflicts. Exit test manifest. All right, so this is easy. We just throw away everything that's stashed. Stashed upstring, yeah. Now we have our initialization test and we're happy. Now we can deal with what is in here. This is our implementation for parsing the parts. Okay. Let's write tests for that. All right, good. Parts parsing tests. Test number 1. We're testing the root, okay? And we already know it passes. Test number 2. No root is parsed correctly. I don't know. Let p equals path C string. Actually, string and C string doesn't really matter. I guess A, B, C. Then assert p dot root is empty. Not sure why highlighting is not working, but test is passing. That's good. P dot root is empty. Okay. It's somewhat counterintuitive, but I think the user will get used to it. Yeah. Because we'll also have like things like root string or something. Yeah. Okay. All right. Test parsing drive. I don't know. Let p equals path string C on POSIX. Okay, so let's see our path is like this. A, B. Oh, we still need to throw away. The split drive still needs to be implemented. All right, so we just don't write. We'll comment out. We'll comment this out, okay? So POSIX, if you write thing like this, we'll say xad assert drive on POSIX. Let's see what happens in Python. If I say Python 3, and then import pathlib dot path C, I don't know, A, B. So it just straight up becomes C colon AB. What if I say C on backslash AB? Yeah, okay. Oh, wait. That's not right. Right, okay. C for assert AB, assert p dot drive is empty. Okay, so that's good. Func test parsing parts. Let p equals path string. I'm thinking we don't need these. Yeah, I don't need these because this is just repeating the type information. Except C string. C string conveys information about null termination. Yeah. Okay. So C string A, B, well, A, B, C. I don't know, something like this. ACT assert equal P dot segments. It's gonna be this. The inside it's A, B, C dot Swift, something like this. Oh, segments. What? Oh, right. So this would be a dot u. Yeah. Is this segment really useful? Yeah, maybe. Okay. So it's array of contiguous array. A dot utf 8c string drop last. Init. This should work, right? Oh yeah. Oh wait, what? Segments is empty. Segments is empty. That's not good. Segments is byte split by separator byte. And then I think it's the filter problem. If the $0 is 1 and the first is current directory byte. Oh, right. It's the thing. Okay. Is the negative of this. So let's do the logic thingy. Okay. Still fails, but we're just missing these two values. I hope. Build failed. Oh, right. Count is not equal to 1 or first is not this. Okay. Now it should pass. Yay, okay. So what have we tested? Oh yeah, the last one. Func test intermediate current directory is removed. And let p equals path string. I'm going to remove all the string colon. I don't know. A dot B dot C equal uh-oh. 97, 98, 99. What? So in that case, count is 1. So we need to evaluate this, which says byte. Why is only 1 bytes here? Forty-six is a dot. Okay. Print $0, return contiguous array $0. Okay, let's do it. Confused. Oh, yeah. What am I thinking? Yeah, of course. It's just a test error. Expectation problem. Okay, so this would pass. And we're good. We've tested everything. Let's see. Nice. Let's write documentation. What do we do? Implement path parsing for POSIX. Nice. Okay, it's almost 2 hours. I'm thinking after we write documentation, we will call it. Okay, so what should we write? Let's just write things that we did today. Or maybe a little bit more. Okay, so there's static stuff. I'm thinking. Okay, I guess before we do that, let me just remove this Sterling because there's not really a point. Var end equals I don't know. Length is 0 while C string dot I don't know. Var end is C string while end dot point T is not 0, and I guess advanced and advanced by 1. Oh, weird. Or rather, C string advanced by length is not 0, length plus 1. Point T. Okay. Calculate C string length manually. I'm gonna assume everything still works here. Yep. The initialization test helps us already. Okay. What part of the public interface are we interested in documenting? I don't know. This is the bytes raw. I don't know. Byte representation of the path. or raw representation of the path in as produced by the this could be a value from the C well, not C API, from the native from the operating system. It's not system API or something like that. I just want to say, like, it's not, you shouldn't expect it to be normalized or anything, right? Yeah. Okay. Could be system API. It's agnostic to string character encoding. Okay, something like that is good. All right, then we can say initialize creates a path from a null terminated string. C string. Okay. We're gonna pass parameter C string from a C string. Okay, so here we have create. Okay, so this is where I also want to do that thing, right? I wanted to do this. Run fix. Nice. I just use Vim. Who cares? Creates a. Let's get rid of this. Then maybe there's a better way to do it. We'll cache this line. Then in the unstaged files, there should be more changes. We can look. So we can get rid of this. Open this. Yep, cache that one. Now we can commit. Remove label from string initializer. it merely repeats the type of the argument. Okay, this is called remove unnecessary needless words. Remove needless words. Okay. Creates a path from a string. Parameter string, the string to create that represents a path. The string will be decoded. Wait, encoded? Encoded as UTF-8. As UTF-8 bytes. Right, when you go to let's just say interpreted. Okay. The drive for the path on POSIX. For POSIX, this is always empty. The bytes for the root. For example, on POSIX, this would be if it's present in the path in bytes. The segments separated by the separates segments in the path separated by path dot separator byte. Okay. Root is not included. Okay. I just realized something. In Python, when you make something like abc.d, the stem and suffix doesn't necessarily mean it's for the file. It's just whatever in the last segment, right? abc.d might as well be a path for a directory. Okay, that's pretty interesting. Something for some reason I was not expecting that, but it makes total sense. Okay. this value is lazily computed when it's accessed for the first time to manually to trigger the manually trigger its computation. Use parse parts. Or just parse, I guess. And I'll add this to all the other two as well, I guess. Because this will be a note. That's fine. Okay. Analyze the parts, the content of the path, so that it's this will result in a cached value for drive root segments and cause the etc. Okay, this is fine. Okay. Separator character for the separator by path separator for the or appropriate path separator for the native to the current operating system. Right, so that's also documented. And we'll write a lot of documentation here, so not today. We'll document these. Yeah, that's good. Oh, stop. Okay, so here we go. We'll just cache everything. And then add documentation for new public interface. Okay. 2 hours, 16 minutes. What do you say we call this a good stream? All right. I think I'm going to call it. Yeah, it's a little bit of a slow start, but I think things are coming along. Tomorrow I'll resume working on this. I think we will try to. Let me think. Yeah, we'll try to implement this for Windows, maybe. I mean, at least I'll fill in the gap for the drive part. Yeah. Or maybe I'll do it offline. And then we'll do things like, is absolute, stem and suffix and things like that. Okay. Thanks very much for watching.